Alright, so now we have our 1.5 kilogram brick again, and now it has moved from hanging on a string to sitting on the table, and we still have Nick with us there. So Nick, is that brick in equilibrium?
Yes.
And how do we know that?
It is not moving.
It is not moving. And Nick, can you tell me a downward force that would be acting on that brick?
Gravity.
Good, gravity or weight. And since it's not falling, what is that? What other type of forces must be acting on that brick there, Nick?
Normal force going up.
Okay, normal force going up. Why don't you define normal force for us, since Physics B hasn't heard that term before. Do you know what a normal force is?
Normal force is the equal and opposite reaction to gravity going down.
That is not correct. The gravity going down on the brick has an equal and opposite force of actually gravity pulling up on the earth. A normal force is a force exerted whenever two surfaces touch. We call it a normal force because it's always perpendicular to the surface, and normal is a word for perpendicular. Alright, so we just talked there about the normal force, and a normal force is a force exerted by any two surfaces in contact with each other. So, when we have an object sitting on a flat table like that, then what ends up happening is that the brick is going to have a normal force that is downward on the table, but then the table is going to exert a normal force that is upward on the brick. And what we care about right now are the forces acting on the brick, so I've drawn my normal force going upward on the brick. And as we said earlier, normal is another word for perpendicular. So what we see is that the normal force will always be perpendicular to the tabletop. The tabletop is a horizontal surface, so the normal force is a vertical force. The normal force, like we said, on the brick would be going straight up, and the normal force exerted on the table by the brick would be going straight down. So for this particular problem, we didn't measure the normal force, but we are going to calculate it, and we see that this is very, very similar to the previous problem that we had with tension and weight, but this time we just have normal and weight. And once again, we don't have any horizontal forces, so all we really need to worry about is that the net force in the y direction is going to equal 0. So N minus mg is going to equal 0. So N is going to equal mg. And since it's the same brick, what we find then is that the normal force is going to have to be 15 newtons. So when we had our brick hanging from a string, we had the string exerting an upward force of 15 newtons that was keeping the brick from falling. Now that we have our brick sitting on the table, we have the table exerting an upward force of 15 newtons on the brick to keep it from falling. And that's it for that problem.